Hi everyone, so welcome to the next video. Today we'll be actually covering the second part of building the web server. The first part we covered how to build the server, that is the socket program, the initial part. In this thing, we are actually uh, going into writing the core logic of the web server. But before getting into that, we need to know how hypertext transfer protocol or HTTP works. So that is the first thing that we'll be covering here, so that we need to know what we are building. Wrong slide. Yeah. So HTTP, if you're not familiar, is present all over the web. It's the foundation of the data communication over the web. Think of HTTP like when you are accessing any internet or any websites, you're logging in somewhere, you are using HTTP. Uh, if you go back in history, it has been in use from the early 1990s. There's something called the requirements for comments, RFCs. In these RFC documents, it has been said the HTTP has been there from 1990. I just want to show you something real quick. RFC 1945 is HTTP protocol. So this is what we are going to be kind of building here. So if you go here, they have actually explicitly said that it has been there in existence since 1990, and it has gone through multiple iterations after that. But in in what we are building today, we'll be focusing primarily on this. So this is how the RFC document kind of looks like. uh, there are multiple thousands of RFC documents. This is mostly written by the IETF. I think it's the Internet Engineering Task Force. Those people are the ones who handle uh, almost entirety of the RFCs. Coming back to the thing that we were doing, the presentation, going back to the slide. So before building the web server, was core logic, we need to understand how the request looks like. We need to have an idea on how uh, the application works like, so that we can build it. So in order to build the web server, we'll be focusing on primarily three things. That is, first one is the get request, second one is the post request, third one is the put request. So the get you use to get files over the internet, you use it to retrieve data. Post, as it's seen in the slide here, it's used to send the data to the server. um, it cannot be explicitly seen um, on the browser's tab, but that's on a different note. And put is to store maybe a file on the server. Okay, I do have a small doubt if I'm recording the video. I'm still recording the video. Okay. So the next thing that we need to know is headers. Headers are really important. You might ask, what is this? What is the need for a header? Think of header as the metadata to the request. It contains a lot of information about the request that is being created by us. For the time being, we'll only focus on a few headers. That is, one is the host, second one is the content type, and third one is the content length. Host basically defines where the request is originating from. So from which domain is the request originating from? Is it from an example.com, maybe from facebook.com, maybe from x.com? uh, so the second thing is content type. What type of a content is the request having? Now you might wonder what that means. The data inside the request can change. uh, it can be of different MIME type. That is, if I'm correct, that is kind of the data type for email extensions, or the data how um, the web servers perceive. Say you are sending a picture or an image or a video, the web the browser needs to understand, or the server needs to understand that, hey, coming data is a video, text, or some random binary data. That is why we need meme types. Third one is the content length. Content length explicitly tells the server how long the request is, or the data contained in the request, how long it is. It is really important so that, hey, think like we both are communicating and you're sending me a message and you're telling me, hey, I'm sending you a file. It is, and if you're telling me how long it is, I can really check the file, like if it is that long, and it kind of creates a understanding that the data size is the same what you sent and what I have at my end. Excuse me for that. Content length basically describes the size of the data, size of the body in bytes. That is basically what it means. The requirement for that is to say that we both are communicating, and when you're sending me the data, you should know how long it is, and when I get it, I should also know how long it is so that I can properly parse the data. That is the reason why it's there. So we'll be only focusing on these three right now. There are many other headers which we won't be discussing today. Now the next thing is the request body and the content. Request body is the main thing here. So post and put requests are the ones that actually require the content length parameter. So this is what I was saying again. It ensures the servers read the correct amount of data actually. Then once the server gets something, right, what should the server respond back with? It should reply back with some message, right? So that is what is here. That is the HTTP status code. So if I'm the server, you send me something and I get it, it's all well and good. I'll say, hey, 200, okay, I got the thing. But if you're trying to get something and it's not in on my server, right, I'll say, hey, I don't have it. Then I'll give you a 404 code. What if you're trying to put something on my server and I cannot actually put it? And I'll show you, hey, I'm not able to put it. It's something in my internal server side problem. So I'm going to throw you a 500 error. There are other errors in the segment as well. You can Google search it and find it out. So this is how the example get request looks like. You have the get parameter, you have the directory and the file name that is there. The slash index.html is the file name, slash you're getting it from that directory, and you're specifying what type of an HTTP request it is. Like HTTP, the initial RFC has 1.0, we'll be just seeing 1.1, and we'll have also the host, that is the example.com, where the request is originating from. So we will have all of that here. This is an example request of a post request. As I mentioned earlier, this will contain the data. Again, it's almost same, but you can see two new headers here, that is the content type and the content length. Content type, you are saying, hey, we are sending a form URL and got a data here, and the content length is 24. We are giving name and country with two values. That's it. Super simple, nothing complex. um, the next thing is the put thing. The put request, we are trying to put it on the server. So you can see I'm trying to create a new file called data.json. I'm telling, hey server, I want to put a file called data.json, and the content type is of JSON format, and the content length is of size 34. So the content length for 34 means, like, from this curly braces to this curly brace, the length is in total 34. That is kind of the similar thing in the previous post as well. From the letter N to letter A, if you take the content length, it's about 24. All right. So once all of that is done, the server will send back with their default request saying, hey, I got the thing, and yeah, hey, and this is the response. So I think that's it. Now we have a rough understanding on what we have to do. So we have to make sure the get request gets satisfied and get a response. The post request gets satisfied and get a response. And the put request gets satisfied and gets a response. That would create the basic web server. All right. So now we are actually going to create the program here. So the file name is the request handler.c. I think I have already discussed about all of these headers previously. There's one new thing, that is the regex. So I'll be handling the content type using regular expressions. So here Let's go to the first part, right? That is the handling of the request. So in the server.c, we were handling the request. So once a child process gets hold of the person connecting, whatever the information the person is sending will be handled by the request. Now that will go right over here to the handle request. You can see that it is taking in a client socket as an argument. Now I have declared quite a few things. Now I have declared a buffer of size 1024 so that I can capture the data coming in. I have declared a method. So think of this as the what type of a method it is: get, post, or put. That's why I have it here. The path, like slash data.json or slash index.html. So that is a path that we're trying to store here. The host is the domain name, example.com, facebook.com, whatever it is, it's gonna come here. Content type, as you know, form URL JSON or application JSON, form URL or whatever is gonna come here. We are gonna capture it here. And finally, we have the content length, which is of an integer value. So I think we covered all of the things that we need to actually store in order to verify everything. Okay, next thing. Next, we are actually reading them from the client socket. So first argument is the client socket, that is the data that is being coming in. Second thing is the buffer. Third is the size of the buffer. So we already know. So this buffer character buffer variable is coming in here. We know the size. It's gonna come here. So very basic stuff. We're gonna create a method to parse the request. So that is the first thing we need to do. So we need to parse the request and check if it is a proper request at all. The server doesn't know what is. Server needs to know if it's a legitimate request. Otherwise, it doesn't even need to, you know, send anything across or store anything on the server. It needs to be in a valid format. It needs to follow the HTTP uh, format first of all. So you're going to parse the request with buffer, method, path, post, content type, and content length. That is all. That is whatever we are creating here. We are gonna put the actual values in here to verify if the request is right or not. Coming back to the parse request headers. Now I have a method that actually parses the headers. You can see all of these arguments are being taken in here. And the first thing is to check check to is to get the method and the path. That is it a get, post, or a put request, and what directory, which file are we getting at the very basic link. So we are doing ss scan of request. We are putting in two strings, that is method and the path. Okay, so what happens is that first the request comes in, right? When the request comes in, we are telling it, hey, so we have the parse request here with all the required arguments. So first thing that we're going to do is that we're going to take the buffer in and we're going to split it up and get the particular parts that we need. You can see I'm doing constant char star of request. That is the one that will be getting the entire buffer or entire contents of the request. So once that comes in, I'm going to do this. You can see 2%s, that is two strings separated by a space. So if you saw the previous slide, right, maybe I'll try to put it here for a second. You can see that the request, it looks like get space slash directory. So that those are the two strings that are there. So we'll be getting the first part, the first get request and the path here. So we'll be able to get all of that from the initial buffer. Second thing is to find the headers. We need to know the headers, which are really important for HTTP requests. We discussed that earlier. Um, so as a str basically checks for the first. It checks for the first occurrence of something. So you have slash or slash n. You don't know what slash or slash n means. Slash or slash n basically means CRLF. So what is CRLF? Let's like quickly do a CRLF search. CRLF. CRLF is carriage return and line feed. Uh, okay, leave all of that. It's basically means ASCII 13 and ASCII 10. That is slash R and slash N. It so the code actually looks for the first occurrence of slash R slash N. It uh, history on that is basically the old typewriters. When you type it, you get to the end of it, you take it off at the end, and you bring it back to the next line, and then you press it there. So saying, hey, the line is ending here, so the line feedback needs to come to the next line. That is basically what CRLF means. So it's a really easy for way for us to find the end of a line. So whenever we need to find the end of a line, we can just look at slash or slash n. A cool way how HTTP was written to. Yeah. So we look at slash or slash n. We find first uh, the first iteration of that, or the first, on the first line we see the get request ends and we see a slash n. We found it. Now we need to, so now the pointer will be on slash r. We need to go after two lines so that we can jump to the next line. That is why we are adding two here. We're coming to the next line. Now the headers actually start. You're just checking if if it is not equal to null. Header end is not equal to null. There is nothing there. If it is it is continuing or not, then we are creating a header line of size 256. Then we are going to do a string copy of header line, the header start, header end. What we are basically trying to do is that we need to find each header lines, and we need to find the header end as well. So that is why we have it here. um, all right, so cool. So now we go to the initial thing. We're gonna do um, string compare. String compare of header line. So we're going to take the header line. We're going to check if host is there. Its size is 5. That is 1, 2, 3, 4, and 5. That is 5 characters are there. We're going to check it is equal to, yeah, that line contains the host. Then we are going to do the scanf of the thing after the host. So example.com, facebook.com, x.com. We're going to take that. Next line, the header line. If the header line contains the content type. So this is going to keep going in a while loop, right? Until this ends. There's nothing there. So we get to the next line. Next line is the content type. Content type is of length 13. It's gonna check that initially. If it is there, awesome. We're gonna do, and we're gonna scan what's the content type. Is it a JSON type? Is it a text or data type? Is it a form or image or video, whatever it is? Then we're going to do the next iteration where we are going to actually get the content length. How long is the content if it is a put or a post request? We are going to get that there. That is actually a numerical value. So that is why we are doing percentage and we are going to get it, and we are going to we are going to get it from the getter line, and we're going to store it. That is, so host, we got the host, we got the content type, and we got the content length, and we are just going to say once all of this is done. So like the loop, every time the loop iterates, we will check for the ending, and we'll just move to the next line. So slash or slash and tum tum tum. So we whenever we get the CRLF, we whenever we get to the CRLF, we iterate two bytes to the right, and we get to the next line. All right. So once that is done, we'll come back to our handle request, where we'll be handling the rest of the things. So um, what if the host doesn't contain anything? Then it's a bad request. So we are returning that in the first check, and we're gonna do another check to see if it is a post or a put method, because the body mainly comes in a post or a put method. Get request usually doesn't have any body. So here we're gonna do the check if it is a post or a put, and this is a cool thing is valid content type. So this is pretty important because we need to check if the content type is of you know JSON or maybe image or whatever it is. So we actually needs to really check if the content type, whatever we are getting it, the server needs to know what it is. I just wrote a method to handle that is valid content type. So content type is given as the argument it takes in, and we are using regular expression here. I already told we'll be taking in regex. Um, so this is basically how you. So this is an integer things to check if it is true or false. That is kind of what we are doing here. So initially we are just gonna compare the regular expression. So this thing says it starts with, so it should, if it is starting with text or application or form. So a sample example, maybe I can show it here right now. Um, text slash form, text slash plain, or text slash data, or maybe application slash JSON. These are all examples. So this is how it should look like. If it is looking like that, then say, hey, hey, okay, this is good. You can go back. Um, I know, and wait a second. Okay, yeah, awesome. Yeah, so yeah, so yeah, so over here we are going to be checking. We're going to be actually checking the regex. So we're going to do the regex. We have all of these here, the current format that we are seeing, composition, and we're going to check the content type, and rest of it's not, it's the normal arguments that is need to be and we're going to check it, and if it's returning one, that is it's true, then it is actually of a valid content type, else it's an invalid content type. So now in this area we can check basically some of the most text based checks here. That is only what I am focused on right now, so we will do all of that. And if it is valid, yeah, we will return it back. We are returning it back right here. So the content type is valid. Awesome. So the next check that I want to do is of the content length. Is the content length correct? So again, I'm going to just check. I could have like combined these two, but I want to split it so that I can talk about both. So here I'm going to check the content length if it is less than zero. If it's less than zero for a put or a post request, it's basically not having any content at all. So I'm checking that if that is the case, it's also a bad request. You can see I'm sending the response type. What type I'm sending it is a text plain, and what kind of a content, what kind of invalid content header. So that is how I'm sending back the response. The send response is actually there in the response.c file. If you right here, you can see I'm taking in the client socket. The status is the 400 or whatever it is. Content type will contain, hey, let's go back right here and check like text or plain and invalid content length. See, content type and the body. That's basically it. We are adding all of that here and sending it across. And what's next? So invalid content length. Okay, now we are just checking the get request. Um, so while you're getting, you need to get actually a file, right? So if there is an HTML file there, I need to get it. So the server file will actually get the client socket and the path. We already took all of it. And if it is a post or a put method, we need something to extract the body. Okay, so two things we need to do. So we'll be implementing both of that over here. The first thing is the serve file for the get request. Say I got a get request for index.html. How is the application going to handle it? I defaultly want to put all the files in a particular directory called web inside the web server. So I'm just defining the path over here and string get the full path to the path. So what it means is that the full path contains .web already, and I'm going to concat whatever. So slash index.html, it's going to come like, hey, dot slash web slash index.html. So this is how it's going to do it. That is basically what's happening here. So so this is, I'm creating a structure for the file. This is really important. It's kind of how you actually read the files. the file, you need to know the file permission if you can, if you are able to read it and all of that. So some basic structures are there. So we are defining that it's already a C pre-built, C internal that is there. So I'm going to check the full file path, and I'm going to give the file stat as well, and checking if it is not non-negative. And SSDIR basically gives a file stat mode. I forgot what this is. It's do a quick Google search on this to get better understanding on what that is. Um, what does ST mode do? Yeah, file types. Oh, I'm sorry. Like, so this is the one actually that talks about the file permissions and the file type. Yeah, awesome. So yeah, so SSIDR, it will check for the file type and the file permission, whether the user that I am, does he have access to that file? And if it is returning false, I'll send back, hey, I'm not, that file is not there, and I'm returning that. If it's not returning a negative value or anything, then saying that file is actually there, then I'll try to read the file, because we only need to read it, we don't need to write it. We'll read the file, and if there is no file, I'll again say the file is not there. But if I get the file, I actually send, hey, I got the file, I'm sending that file as the file response. So this is send file response. You can just go to the response.c file. I have already written it here. So the type status 200, okay, content type, the file, so all of that is being sent. So fseek actually will seek the file, it will send it out, and I'm actually reading it here. This is the response. I'm writing the response here, and yeah, that's basically it. So reading the buffer from that, whatever I'm getting it, and I'm writing it, and that's it. I'm sending that all along. um, yeah, I think this response is coming for the put request, so I'll discuss that in when I'm covering that. Okay, so once we have extracted the entire body, we are gonna actually check for the body. Like, is there anything of meaning there in the body at all? This is particularly for the post request. So I'm gonna string compare. If it is a post, then I have a method to handle the post. I have a method to handle the put. Otherwise, I'll be sending the response saying, hey, bad request, dude. Sorry, not gonna get anything. Um, or, hey, this method is not allowed if the initial thing where the request itself is wrong. So the first thing is the post request. I'm handling it over here. Taking all of the information, the body, the path. Um, Nothing much here. I'm just sending, taking the response body and the size of it. I'm getting the data right. I'm just gonna just receive the post request here, and I'm gonna send the response. Hey, I got the post request. Nothing much to see here. Second thing is actually handling the put request. So it's pretty long, meaning I need to actually write contents for the put request here. So that's why I have it here. Um, Again, path is defined. Adding the concatenating the path. You saw the data.json file earlier, so data.json is gonna come here. I'm gonna open. I'm gonna create that. So if the path is wrong, right? Hey, I cannot create the file. But if the path is actually right, I'll try to write it with the content length and the whatever the file contents that they have actually sent. And I'm going to send a response back saying, the port data is stored in the particular file in the path, and hey, it's all good. The response actually got successful. But meanwhile, I think I didn't talk about one particular thing, that is, extract body. We never extracted the body. I never talked about the function extract body. I added the extract body. method here as well. So extract body, as the name suggests, I'm going to extract the entire body for the put and post request. I'm going to check for CRLF. So cool thing. So when your request actually gets over, right? Like, the headers all stop, you have two CRLFs, right? So that is like two new lines. So the data only starts after that. So I'm going to find that thing, and I'm going to, so that is four, like one CRLF is two, one another CRLF is two. So I'm going to jump by four. So I'm going to jump by four, and that is where the data is going to start. And from there to whatever is the end is what the body will contain. And I'm going to get the length because we need the content length of that. We already are storing the content length previous, but we just need to do a check as well. I'm just getting that return and returning it that. So that is what is being sent back here. Think, uh, yikes, where is that? Where is that? Extract body right over here. All right, so I think I handled, I told about everything. Yeah. Size byte read, f read. I'm reading the file and I'm writing the file. So this is for writing the file and sending the response. Let me just check the put request very quick to check if I'm doing the same thing. Parse so file, handle put. See, I'm sending the response, then response client socket, response body. Yeah, kind of basically what's happening here. Yep, that's it. And response, status code, content type, and file. Awesome. So I think we covered everything. So last thing to do is to just compile. So I created a make file. So if I do make, or it should make everything. So make file in C is the easiest way to like compile uh, large code bases. So you can add where how to compile each file with what all flags. You can see I'm doing GCC wall include source main, and I'm compile that, create the object here, doing all of that, and finally use all the objects to create the server. And yeah, and I have the server here. So if I do dot server, I have the server running here. And if I do have a call, yeah. So let me just go up real quick. So I'm running it on port 1337. So I'm just trying to show you an example where I'm sending in a put request and storing the data. I'm sending it of the type JSON, localhost, the content length. This length is actually of 34 in size. So if I come back here and if I send it, right, it's telling me, hey, the put data is stored in slash data.json. So we are okay with it. But I don't. We should be actually receiving the HTTP response. So I don't know why it's not getting that. If we go to the folder real quick, uh, and we go to web, hey, we got the data.json over here. And if you try to do localhost in 33, so I already have a index.html file that is there. I inspect it, and if I just check application, the network, yeah, you can see basically how, I don't know if you are able to see it, but you can see status code 200, I'm getting it. The index.html, you can see the basic headers that we are getting. uh, so this all looks really really good. And yeah, that's how you create a web server. Now this is going to be a pretty long video, but yeah, if you're trying to learn about web, try building a web server of your own. You will understand a lot of concepts, and main thing, you will be a better programmer. So wishing you all a good day ahead. Thank you for watching. Over and out.